Okay, to illustrate what we've been talking about, especially in part three, this is part four. Um, I went into the technician pool and pulled out two Ohm's law questions. And first of all, how do I know that they're Ohm's law? Because they're asking about the resistance in a circuit that has a certain amount of current, um, or there's a certain amount of resistance that's unknown with a certain amount of current that's given a certain amount of volts. Okay, that sure sounds like Ohm's law. Now, we could just plug and chug here, but let's take a look at how to approach the problem. I'm reasonably sure that when you go into any testing center, you're allowed to get a piece of scratch paper from them, and if they don't allow you your own calculator, they will have calculators you can borrow. But don't take any kind of a graphing or programmable calculator. Just take a simple scientific calculator. These little Casios, you can get them over at Walmart. They're dirt cheap, and they make one of the best scientific calculators. I'm very much impressed. I've used them all. I've used all the high power HP and TI calculators, and even Casio has one that solves calculus and higher problems. But these little scientific calculators, for the few dollars you pay for them, boy, they're really worth it. Okay, let's get to the point. All right, you might put down on your scratch paper somewhere that V is equal to IR. This equation is already solved for voltage. So if they give you current and resistance, you can just multiply the two together. And I recommend that you use your calculator for doing any of the arithmetic and get the voltage. But here they want to know what the resistance is. So I need Ohm's law, but I need it solved for R. So I will divide both sides by I. That lets that cancel out. And R then is equal to V over I. As a matter of fact, I'll just write it over here. All right. So R then is equal to V over I. This way, all I got to do is take the information that they give me and plug it into the formula. So I have 90 volts. So I have 90 volts divided by 3 amperes of current, or 3 amps. And of course, we're going to get 30 out of that, but I'm going to do it on the calculator since I'm horrible at arithmetic. Okay, my algebra students always laugh when I tell them that, but it's true. Okay, as predicted, we get 30 ohms. And the omega symbol is for ohms. Is there one of those answers? Yes. B right here is 30 ohms. All right, good. Make sure that you understand this process. This bears repeating how to solve these equations. I did it in just kind of one little video, but you need some practice with that. You need to get comfortable. But when you're actually doing the test, so you can use your knowledge. Or, if you're really comfortable using this for solving Ohm's law, that's great. But you're going to have some power problems, and power also kind of follows Ohm's law pattern. So I think it's better to memorize the actual formula, one of them, and know how to solve for the others. That skill comes in handy. Circles can come and go. This is never going to change. All right. And then once you get your formula, plug in the values, do the calculation, get your answer, and find it on the list. If it's not on the list, then maybe you did something wrong. So recheck your arithmetic. All right, let's go down here to the next one. I didn't realize I got two of them asking the same thing. That's okay. Doesn't matter. Repetition is good. So they're asking, what is the resistance of a circle for which the applied voltage is 12 volts and the current flow is 1.5 amperes? Okay, what don't we know of the three values? Well, they're giving us volts, they're giving us amps, so it's resistance. And they say, what is the resistance? Okay, I'm sure that's obvious to you. All right, same thing. Start by writing the formula down. Resistance is equal to the voltage divided by the current. Then fill in your values. That way, if you make a mistake, you can go back into your work and maybe find out where it is. I don't know about you, but when I sit down and take a test, I get so nervous I can fly. So it's just the way it's always been for me. All right, so 12 volts divided by 1.5. And since we have a decimal number here, definitely use the calculator. Okay, so we want to know what 12 divided by 1.5 is. So enter in the 12, divide by 1.5, and we get 8. So this is equal to 8 ohms. You should always label your answer with the proper unit. Hopefully you can draw better than I can. And do we have 8 ohms here on the list? Yes, we do, right there. So you circle that and go on to the next. Okay. Let's take the few remaining minutes and kind of recap this idea of manipulating the equation. You do have to remember one of them. And I, for whatever reason, always remembered E equals IR. And here now we're doing V, spells veer, if that were a word. Okay, if you can remember that, then that gives you the first equation. And for simple Ohm's law, there's just 3 equations. This one is solved for V, so I want to get the one for resistance. We already know what that is, but let's solve it. So V equals IR. I want R by itself. I is multiplying R. To get R by itself, I need to divide by I. Because if I divide by I get that I over I. And anytime the top and bottom are the same, regardless of value, it has to equal 1. And 1 times R is just R. So we're going to divide by I. Those cancel. And we see then that R is equal to the voltage divided by the current. And then lastly, let's solve the equation for I. So V equals IR. What do I need to do? Well, there's my variable I. What's being done to it? It's being multiplied by R. How do I undo multiplication? I divide. And I have to do it to both sides of the equation, and I'm going to divide by R. Not 2. I don't know where the 2 came from. I think that's so funny. Okay, we have to divide by R. So current then is equal to the voltage divided by the resistance. So now any of the simple Ohm's law you should be able to do. If you can remember Ver and the steps for isolating the I and the R to give you the other 2 equations, you can solve all the Ohm's law questions in the book. Now the power ones get a little more complicated. Well, they look more complicated, but it's the exact same process. And we'll handle those when we get to them. But I want you to practice this. Do it more than once, especially if you're rusty at your algebra. All right. See you in the next video.